Welcome to the second video in the series called Video Standards, Signals, Formats, and Interfaces. Good color rendition is one of the most important issues. Today you'll learn more about colors in the video world. Our modern understanding of color perception is based on more than 100 years of research by many eminent scientists. In 1931, the CIE established the definition of XYZ color space, and since then it has been adopted worldwide. In this system, any color, meaning spectral energy distribution, is described by three numbers, x, y, and z values. XYZ vectors can be easily converted into an RGB color space, which is more suitable for signal processing and rendering on televisions. Important though, the CIE RGB color space is only one of many RGB color spaces, and they're distinguished by their particular set of three primary colors. Any change in color primaries requires recalculation of RGB values, or else the viewer will see distorted colors. All colors described by any given combination of R, G, and B values will look the same, although their spectral distributions may differ by a lot. There's a feature of human vision known as metamerism. Colors that match up in this way are called metamers. An RGB display always generates metamers, so color reproduction is a wrong term. An RGB display is not capable of replicating an original spectrum, and that's why the correct term is color rendition. Therefore, color television is ultimately an illusion, or a friendly cheat if you like. By the way, cheating twice seldom works. That's why pointing your camera at a TV screen never gives you good colors. Standard definition, high definition, and ultra-high standard definition systems, sometimes called UHD or 4K, each use slightly different color primaries. Recent advances in display technologies resulted in a much wider triangle of color primaries for UHD. But this improvement affects only the rendition of supersaturated, vivid colors, which seldom appear in real life. Note that a human face or flesh tone, grass, skies, red flags, and other common colors falling within the smallest triangle in this illustration will look exactly the same on standard definition, high definition, and ultra-high definition screens. YCbCr, also known as YUV, is a family of color spaces used as a part of a color image pipeline in video systems. The big advantage of a YUV color space is that any errors in UV or color difference signals, such as a significant loss of sharpness, are much less notable than their corresponding errors in an RGB color space. Note that not all YUV colors have their equivalents in an RGB space. Those YUV value combinations are often called illegal colors. This example illustrates the level of sophistication needed for setting up and checking modern video equipment, including standard dynamic range and high dynamic range displays. Any new technology requires new tools, but even the most sophisticated tool should be easy to use, like this VideoQ Color Space Explorer. This video was prepared for you by a team of experts. Produced and narrated by Joseph Mark, a member of SMPTE's HDR committee. Written by Dr. Victor Steinberg, co-founder and president of VideoQ, technical awards winner, and author of the Video Standards book. Conceived by Roderick Snell, co-founder of Snell & Wilcox and winner of several technical Emmys and Queen's Awards. Technical consulting by Maxim Lefkoff, author of the Video Encoding Cookbook. This video series is brought to you by VideoQ, and you can download these slides and this video from VideoQ.com. VideoQ makes products and services for all sorts of video and audio processing and quality assurance. Based in Silicon Valley with software developers and distributors in several countries. Thank you for watching.